If we have an arithmetic sequence and we want to find the sum, we have a formula for that. S sub n, the sum of an arithmetic sequence, this is the formula that we learned before the common session. The sum of an arithmetic sequence is 1/2 times n times a1 plus an. So we want to find what does the sum equal. Now, we're not adding up every single term of the sequence. Rather, we're only adding up the first 55 terms. So I want to find S55, the 55th partial sum. 1/2. N, of course, is 55 because we're adding up the first 55 terms. A1 is, of course, 2. And AN, well, we don't actually know that. We want A55. We want the 55th term. Unfortunately, we don't have a 55th term, but once we can get it, if we can get it, then we'll be in good shape. The way to get the 55th term, of course, is to plug in 55 for J. That will give you the 55th term. So, on the next page, let's find that 55th term. So we want to find the 55th term, so A55 equals 3 times 55 minus 1. 3 times 55 is 165, minus 1 is 164. So 164 needs to go in here for A55. S55 is equal to 1/2 times 55 times 2 plus 164. I have no idea what the answer to this is, but I do know that I can punch it into my calculator and find the answer. Let me go ahead and do that. And I get 4365. 0.000. That is the answer to this sigma notation problem. Any questions? You don't, but I think it's a good habit to always put the 3 decimals.
For these, we're always finding the greatest, the greatest term, like the 55.
So we got that term 55, which we needed for the equation, right? And then this is actually the sum. So if you add up A1 plus A2 plus A3 plus A4 all the way to A55,
So
then
you're
you
finding
get
all
this.
the sums of.
We're just like adding them all together. Other questions on problem number 8? Leslie.
So when it says find the value of, you're trying to find the sum or the...
Find the sum of terms.
So for number 8, it says...
Yeah. Right. Because this means sum. This symbol means sum.
Oh.
Good question. Go ahead, Edgar, and then we'll come to Abraham.
45.
You plugged in 1/2 times 55 times 166?
Yeah.
You sure? So did I. Good point. So that's number 8. Alright. Let's turn the page and go to problem number 15. Problem 15 says alright. When I look at this they've given me the common difference here. which means we have an arithmetic sequence. It's an arithmetic sequence. Because it's an arithmetic sequence, we know the formula for sum is equal to 1/2 times n times a1 plus an. So let's plug in what we know. This is 2700. We don't know n, of course, because that's what we're solving for. a1 is 5, and we don't know an either. This is slightly problematic, because there are two variables I don't know, and only one equation. So I need to use a different equation to help make this a little bit easier. And the other equation I'm going to use is, because this is arithmetic, I'm going to use that an equals a1 plus n minus 1 times the common difference. Remember, I know this equation applies because it's an arithmetic sequence. So I'm going to take this and put it right here. Why is this beneficial? Because it removes one of the variables that I didn't know and gets everything in terms of n, which is what I'm solving for. So, writing this differently, I have 2700 equals 1/2 times n times 5 plus this is what we've done. And now, all we need to do is plug in what we know. We already know a1, we already know d. Let's plug those in. Any questions on this before I start plugging in? So you're just going to plug in what you know for a1 and what you know for d. And now you're going to follow Mr. Kurtz's strategy of peeling the onion from the inside out. Start inside and work your way out. Just continue to peel the onion from the inside out. Again, continue peeling from the inside out. Now the inside is done, so continue simplifying. So
I thought it was plus 2, not negative. Plus 2n.
right? So 5 minus 2 is 3. I'll blame it on the medicine I'm taking. 2700 is 4n
Is this squared?
plus n squared. When you get to this point, there are three ways to solve this problem. Some of you will want to use the first method. Some of you will want to use the second method. And those hyper-efficient ones of you will want to use the third method. Any of the three is acceptable. When you do this, of course, you'll find two roots because this is a quadratic, but only one of them is positive. Of course, we only care about the positive root because you can't have a negative number of terms. Questions? Question? No. So any questions on number 15? Okay. So let's take a 1-minute break and then we'll come back together. So do what you need to do for a minute.
Ready to get the answer?
Back. Alright. I'd like to talk a little bit about geometric sequences. So first a few notes and then we'll jump into some problems. A geometric sequence is any sequence
So you gave me for further.
whose terms are found by multiplying the previous term by a number. This number is known as the common ratio. Which we'll of course abbreviate as R. Now, just like for arithmetic sequences, there are two important formulas for geometric sequences. We have the nth term formula, which of course is an equals a1 times r to the n minus 1. The nth term. This is the first term. So we have the nth term formula, and then we also, like for arithmetic, have a formula for the sum. That formula is Sn equals a1 times 1 minus r to the n all over 1 minus r. Again, r is the common ratio, n is the number of terms, and a1 is the first term. Now, any questions on the two formulas or what the variables stand for?